Hello friends, today we'll be talking about odds ratio. Uh, odds ratio is a measure of association that is used to quantify relationship between odds of exposure among cases and odds of exposure among controls in case control studies. Okay, so like I've said, when we're talking about the exposures, we study exposures in case control studies. Okay, where we have cases and we look back talking about what exposures they faced that could have led to the disease that they have. Okay, that's about the odds ratio. So one other thing to note is when you have an odds ratio of 1, an odds ratio of 1 will indicate that the odds of exposure among cases is similar or is the same as the odds of exposure among controls. Meaning that in such a case, we will say there is no relationship, okay, of an exposure to the disease. Then an odds ratio of greater than 1 will indicate that there was a relationship between exposure and the disease, and depending on how much, okay. For example, an odds ratio of 7, okay, would indicate a strong relationship, whereby an odds ratio of maybe 1.2 would indicate a less strong, okay, relationship between exposure and the disease. Okay, meaning when you've got an odds ratio of greater than 1, it will indicate that the exposure is the risk factor to the disease. But when you have an odds ratio of less than 1, it would indicate that possibly the exposure could be a protective factor to the disease. So now let's look at this question. This question is saying we are going to calculate odds ratio. So the question says in May 2023, a health department in Chipara district of Zambia was notified of an outbreak of food poisoning following having eaten meat at a wedding ceremony. 55 out of 60 case patients and 21 out of 45 controls reported having added some tomato sauce to their meat. Part A is saying, is asking us to draw a table to display the data. Okay, so I'm just going to draw a simple table, a very simple table, just to help us understand what was going on. So okay. So here I'm going to say disease group, cases, controls. Okay, and here I'm going to say okay, risk factor. Okay, so we've got a group that our risk factor here is the tomato sauce. Okay, because they all ate meat, but some added tomato sauce. So our exposure or risk factor is the tomato sauce. So we're going to have the first group that added sauce, another group that did not add sauce. Okay. Then so we're being told in this forum. I'm going to say totals. Add the totals. So I've been told that amongst the cases it's 55 out of 60. So the total was 60. I'll start with the total 60 here. Then 55 added the sauce. So meaning that only 5 did not add sauce. Okay, then the other group is indicating to say 21 out of 45. So the total here is 45. Okay, then here 21. 21. Meaning here we have 45 minus 21. So roughly 45, 21, this is 4 to 24 here. Okay, I'll add another, increase the table. I'll extend my table here. I'm going to say totals again this side. So I'm going to add this number, I'm sure it's going to give us the 76. This is 29. When you add 76 plus 29 or 60 plus 45, we'll get the same total here. Okay, so roughly, this total is telling us that these are the people who ate the meat at the wedding ceremony. So that's part A. Part A was just telling us to draw a table. Then part B is asking us to calculate the odds among cases and odds among controls. So I'm going to label my table. I'm going to include some letters here. This is A, B, C, and D. Okay. So among cases, odds among cases is equal to A over C. Okay. Which of the 55 over 5. Okay. So calculating 55 divided by 5. 55 divided by 5 is giving me 11. That is our answer. Then that was part 1 of D. Part 2 of B, odds among controls equals B over D, which is 21 over 24, which is equal to, I calculate this 21 divided by 24. Okay. 0.875. That is it for part B. Then part C. Part C is asking us to calculate the odds ratio. So odds ratio, in short OR, of A over C, okay, divided by B over B over D. Okay, so in short, if we say A over B, we found to be 11 here, divided by B over D, found it to be 0.875. Okay. Okay. So 11 over 0.875, which is equal to 12.57. That is our odds ratio. The other way was going to be, if we wanted, we are going to use this. If we want to introduce a multiplication sign here, we can say A over C times Z. Following the rules of mathematics, D would come here on top, D over B, which is, this is going to be A times D over C times B. Okay, you can still follow from our table. A times, which is A is 55. 55 times D is 24 over C is 5 times Z, B is 21. So if I punch this, I should get the same answer as we found using another method. So I'll say 55 times 24 divided by 5 times 21. Okay, so it's giving me 12.57 as our odds ratio. Now, what this means is, okay, the the odds of exposure among cases was 12.575 times, okay, compared to the odds of exposure among controls. And we said when the odds ratio is greater than 1, it means that there was an association. And looking at 12, it is telling us there was a very strong association. Okay, that is our interpretation. The odds of exposure among cases was 12.57 times more than the odds of exposure among controls. Meaning that the tomato sauce in this case was a risk factor to the disease, to food poisoning. Okay. So we end here today. This is about odds ratio. I think I'm sure next in our next video we'll be talking about risk ratio. Okay. So please, if you like the video, kindly subscribe, and see you next time. Thank you.